All right, so now we're going to be determining end behavior and also talk a little bit about multiplicity when it comes to graphing polynomial functions. So end behavior, we spend so much time looking at x-intercepts and y-intercepts that we forget that there's other parts of the graph that go shooting off. I spelled determining wrong. Good heavens to Betsy. Determining. Oh my gosh. Determining. I'm sorry, that's going to crack me up. Determining. All right, so determining end behavior. So we spend so much time looking about what happens around the origin, you know, kind of, all right, hang on. So around this area. So we're like, here's x-intercepts, here's y-intercepts, you know, is it going up, is it going down? That we forget to determine his end behavior. And I keep saying he because for some reason graphs are he's. So what we want to look at is what are the arms doing? Or what are the tails doing? That's what our impression is with this part. So you also need to look at, it kind of has to do with increasing and decreasing. So if we look at some basic stuff, if I graph y equals x, if I graph y equals x cubed, if I graph y equals x to the fifth, all of that should have something very familiar, because if you'll remember, y equals x is just the identity function, and so it's x to the first, but it's in opposite quadrants. And then we have y equals x to the third, which looks like this, and then we have y equals x to the fifth, which is a little bit steeper and flatter. Okay, so the end behavior, if you'll notice, it all kind of sort of looks the same in here, but it also all kind of looks the same on the tails. So basically, is if you have an odd exponent, then your function is going to shoot off in opposite directions. So the right side is going to shoot up and the left side is going to shoot down. Well, what happens if we flip it? Okay, if we flip it, so if I have a negative x or a negative x cubed or a negative x to the fifth, well, here's your negative x. Here's your negative x cubed. And then here's your negative x to the fifth, like that. And so now look at the red stuff. If I'm looking at the red, then as I go to the left, he shoots off in an upwards direction. As I go to the right, he'll shoot off in a downwards direction. So an odd exponent still will be shooting off in opposite directions. So what happens if we look at an even exponent? So if I've got y equals x squared, y equals x to the fourth, y equals x to the sixth. Well, if I have that, here's x squared. That was lovely. Okay, here's x to the fourth, here's x to the sixth. But notice it just gets steeper and flatter, but his arms shoot off in the same direction. Okay, what happens if we flip it? So if I've got a negative x squared and negative x to the fourth and negative x to the sixth, well, now it's all going to be going like this, and it's going to shoot off in the same direction. So when we're talking about end behavior, we want to look at what the tails are doing, or what the arms are doing. Okay, same thing. So it just, and I'll say tails and arms. I just mean the stuff on the end. What's happening with that stuff? So the next thing we need to look at is multiplicity. So I'm going to give you an arithmetic example of that. And if I break down 100, okay, you could say, wait, you know, that's 10 times 10. Great job. Okay, can I break that down further? Yes, this is 2 times 5 and 2 times 5. So how would I write that? I would write that as 2 squared times 5 squared. So basically multiplicity means that the same factor pops up multiple times. So in this case, 2 popped up twice and 5 popped up twice. So this is an arithmetic. Well, what happens if I show you something like x squared plus 4x plus 4? Well, I can factor that. What are two numbers that multiply to 4 and add up to 4? Well, that's going to be x plus 2 times x plus 2. And I'm too lazy to write it that way, so I say x plus 2 squared. So what you have is multiplicity. X plus 2 is a factor that occurs multiple times. Or you could say that the intercept of negative 2, because negative 2 plus 2 is 0, the intercept at negative 2 has multiplicity of 2, because it happens twice. So what does that mean? And I'm just going to make something up here. if I have a negative x plus 4, x minus 3 squared, and x plus 5 to the third. Okay? First of all, I know it's negative. So I know whatever this thing is, it's gotten flipped. Okay? The second thing I want to know is how many things are being multiplied together. So this is one factor. This is two more factors. So this is 1. This is 2 more, and this is 3 more. So what I have is this thing has an exponent of 6. So what you're going to do is add up your exponents, and don't forget about the 1. Okay, so there's 6 factors here. It's just this one repeats itself. This one repeats itself. So if I wanted to be not lazy, I would say x plus 4 and then x minus 3, x minus 3 again, x plus 5, x plus 5, and x plus 5. So I've got 1, 2, 3, 4, 5, 6. So this thing is an x to the 6th that got flipped. So here's what I know right now. I know the basic function are his tails go down because he is an even, okay? He is an even function and he got flipped. So x to the 6th looks, where did my paper go? X to the 6th is just going to be a flipped x to the 6th. Well, now I can start looking at the nitty gritty stuff. So again, if this was my starting point of something I just made up randomly, okay, I know that this intercept is at -4. So I'm going to put him, and this is not drawn to scale. Okay, so I've got that intercept at -4. He appears once. What you will find out is that if you ignore this whole thing, what does that make if I graph it? That makes a line, and he slices through. Okay, so let's try it again. Let's look at this one. What's your intercept? Your intercept is at 3, and it appears twice. So over here, I have an intercept at 3, but he appears twice. On this one, I've got an intercept at -5, which is going to be over here. So this is -5, -4, and 3. And he appears 3 times. What does that make if I graph it? That makes a cubic function. What does that make if I graph it? It makes a parabola. What does that make if I graph it? It makes a line. So those little bits and pieces of the graph are going to take those shapes. Okay, so if I come and look at -5, simply because he's the leftmost one, what's going to happen? That means I'm going to come up with this thing, and I'm going to have that little hiccup like that. Okay, a little hiccup like that, as if just that part was cubic. Just that part. Okay, what happens at -4? So let's go over here, -4. He's going to slice right smack through. Well, that means I got to come down somehow. So he's going to slice directly through, just like a line. What happens at 3? At 3, it's a parabola, so he's going to come up, bump off, and then drop back down. So that right there is a parabola. Okay, so at -5, you had a cubic. So he had that little hiccup like a cubic function does. At -4, he's a line, so he just slices through. And then what happens at 3? At 3, he's a parabola, so he's going to come up and bounce off. And then he will join this back there. Now, this is like the roughest, ugliest sketch in the whole wide world, because I don't know how tall this goes. I don't know how low that goes. I don't know anything. Okay, but at least I know what it looks like at each intercept, and I know the tails. I know what the end behavior is. So that's what we're going to be looking at the first few examples. So I'm going to go ahead and pull some up because we still have a solid, I like to keep the videos at like 15 minutes. Actually, I'm going to stop here so that I can flip back and forth between my screen and my paper. So I lied. We are not continuing on until next video.